Can you feel that the greenhouse effect is going to take its toll, let's say the next winter or two that it has been, and actually maybe getting warmer and maybe having more rain than snow? Thank you.
Let's direct that question, if we may, to Dr. Michael Oppenheimer. Can you go ahead with that question, please, Dr. Oppenheimer?
Sure. It's never possible to predict the consequences of the greenhouse effect in any one winter or any one summer. What we know is this. Over the last 100 years, the Earth has warmed about 1 degree centigrade, and we predict that unless the emissions of the greenhouse gases are limited, that warming will continue. We think we're seeing the consequences of that warming already. 5 out of the last 8 years have been the warmest in the historical record, which goes back about 130 years. And we project that over the next 100 years or so, the mean temperature of the Earth could warm 3 or 4 degrees centigrade. That's about 6 to 8 degrees Fahrenheit. And for comparison, just so you understand what that means, during the Ice Age, when a good deal of the Earth was actually covered with ice, we were about 8 degrees Fahrenheit cooler than we are now. So we're looking for major changes in the future. But you can't say for sure what will happen in any one year because, as you know, weather is highly variable.
So, but you think the overall trend would probably be to see a gradual increase in both the winter temperatures on an average as well as the summer temperatures?
In general, globally average, one would expect both the winter temperatures and also the summer temperatures to increase. But there could be particular locations where one might actually get cooler winters. And one possibility that's been discussed, for instance, is Northwest Europe. As you know, England, other parts of Northwest Europe have mild winters. That's because of the Gulf Stream. There's the possibility that the warmer global temperatures will lead to a shift in the Gulf Stream and actually make Northwest Europe's winters cooler, even though the world as a whole is warmer.
Okay.
There's a lot of variability in the system, and the details are very difficult to pin down.
So don't just look at the little bumps, look at the overall trend.
That's correct.
Okay. We have another question on the line. This is coming to us from Miami, Oklahoma. Go ahead, please.
Yeah, my question pertains to the jet stream. I hear a lot of conflicting reports that indeed the jet stream being too far to the north has caused the drought. I just wondered what your input is on that.
Dr. Grims, would you like to elaborate a little bit? Maybe he's referring to the jet stream's position and what we're ending up seeing, and maybe is this drought caused necessarily by the greenhouse effect?
Well, the greenhouse effect is really just a prediction that the temperatures will be rising slowly. Mm-hmm. And whether this has an immediate impact upon position of the jet stream is a question of debate.
It almost kind of echoes what Dr. Oppenheimer was just talking about, where don't look at just the little perturbations in a year-to-year basis, or the jet stream right now is leaving us in a position where we are affected by a drought in the United States, but look at the overall trend that may affect us for years.
Yes. Mm-hmm.
Okay, very good. Next question comes to us from Pittsburgh, Pennsylvania. Go ahead, please.
Yeah, now this greenhouse effect that's now going on, if it gets any worse, do you think that the animal population will start to die off drastically? And I have also heard that there is a hole in the ozone layer. Now, where is this hole located at in the ozone layer, and how big is it?
Okay, 2 questions. And again, let's direct this to Dr. Oppenheimer if we can. The one question came to us concerning, and we know and we have been discussing how the humans may be affected by this gradual greenhouse effect, but how about the animal population? I know it had some effect with the dinosaurs in many eons before. How would it affect the animal population? Let's go ahead and attack that one, and then we'll answer the question about the ozone layer. Dr. Oppenheimer?
Well, to really appreciate what the greenhouse effect will do to natural environments, and that includes, for instance, the animal populations, you have to understand that not only animals, but trees and everything that lives on the face of the Earth is adapted to live in a particular type of ecosystem. And the appropriate climate to let that ecosystem survive is going to move. So that, for instance, the appropriate climate for Rocky Mountain National Park or Yellowstone National Park, which now sits in the middle of the United States, will move to much more northerly latitudes as the climate warms and as the temperature at a particular location moves north. Now, it's difficult for those ecosystems to move. Animals can move, but the trees, the whole vegetation that supports them can't move because trees don't have legs. The only way trees move and other vegetation is by spreading seeds northward. That is a process that occurs rather slowly. So there's a very good chance that animals, plants, trees, everything natural will have a more difficult time in the future. In fact, I would say that if the greenhouse effect comes on as predicted, the future is going to be difficult for societies, but impossible for many natural ecosystems, and that includes animal populations.
Okay, we'll be directing that ozone question maybe a little bit later on in a special presentation. We'll be talking specifically about the ozone layer. Right now, we want to take a call from Valparaiso, Indiana. Go ahead with your call, please.
Good evening. My question is, what would cause the greenhouse gases to cause the climate change to take place rapidly instead of very slowly?
Okay, Dr. Grams, would you like to attack that one?
I think that what we are trying to, the point we're trying to make here is that the carbon dioxide, for example, is slowly increasing to the point where the calculated increase in temperature has been so small that it'd be hard to perceive. But over the years, it has built up to the point now where people have begun to expect that you will see a amount of warming that can be detected if you have good enough data to verify that the global temperature has in fact started to increase. It's just a matter of degrees. The first few years of adding the carbon dioxide has such a small amount that you can't perceive it. It builds up year after year after year to the point where eventually the predicted amount of temperature increase will begin to be comparable and perhaps even exceed the normal fluctuations you'll get from year to year as a matter of random occurrences.
Mm-hmm. So again, it's not necessarily like we have talked about before. We're seeing a drought this year, and we're saying, look, this is what the greenhouse could be affecting us in years to come. Don't single out this 1988 as we just now jumped into a greenhouse effect. It's actually been accumulating for years. It's just this particular event kind of focuses our attention a little bit more on it.
I think that's true. It's got the public's attention because it's a very dramatic occurrence. We would expect that as the temperature were to increase slowly, the frequency occurrence of droughts might increase because you have more conditions where the temperature is warmer.
Okay, very good. Very interesting topic. I hope you'll stay with us here on the Weather Channel. This special edition of Drought Watch. Again, our telephone number is 1-800-541-6056.
27 years old, and his company was just purchased for $10 million. 34, and she was just made vice president of a well-known bank. 45 and sailing the Pacific for a year. You may wonder how these people do it, but they're just like you and me, sharing the same desire for success. And while there's no one formula for success, there is one magazine with information to improve your portfolio, your career, your lifestyle. With your paid subscription to Fortune, receive this investor's guide, plus this free Fortune Facts with calculator, calendar, and business planner, which is being used by this 47-year-old president of a successful medical company. Call 1-800-727-2800. Get 17 issues at almost 50% off the cover price, payable in 3 installments of just $9.97 each. That's something even highly successful people can't turn away from. 1-800-727-2800.
Stay tuned for the Days In 5-Day Business Planner, keeping track of storm systems, hazardous weather, and poor road conditions that may affect your business travel. The Days In 5-Day Business Planner coming up in just a few minutes, right here on the Weather Channel, only on cable.
The 36-hour forecast. The 5-day forecast. Stay tuned for more weather updates. here on the Weather Channel.
At about 16 minutes past the top of the hour, thank you so much for joining us on the Weather Channel on this special edition of our Drought Watch. We're talking about the greenhouse effect tonight. And Dr. Grams is with us from Georgia Institute of Technology. How about if we just first of all establish how we measure it and how do we know that as much carbon dioxide as what we're describing is now showing up in the atmosphere?
Well, I think it's probably appropriate to point out that beginning in 1957, that observations of carbon dioxide have been made at places like the Mauna Loa Observatory in Hawaii. And the chart that I have indicated here shows the record we have. The early observations are based upon guesses of the amount of production that occurred in the atmosphere since the Industrial Revolution began, and we've got various people's guesses with different assumptions about what will happen over the years as the carbon dioxide increases. The next question would be, we've got some data on current carbon dioxide amounts and the increase and the projections, and then the modeling has to be applied to those higher levels of carbon dioxide. The effect of these models would be to show a small amount of temperature increase as you increase this carbon dioxide by the part per million each year that is increasing.
But are these taken just at Mauna Loa, or are they taken other places?
Well, they're taken at other places on the globe also. But the people generally do look at the Mauna Loa Observatory as a place with data that is not being influenced by local industry and changes of that type.
Okay. We had a special drought symposium that we had here earlier this month. In fact, the Weather Channel Drought Symposium brought together some of the country's leading atmospheric scientists. They gathered in Atlanta to discuss the current drought. Among the topics explored was the greenhouse effect and its relationship, if any, to the drought. A controversial subject, opinions on the greenhouse effect are diverse and many. The day-long symposium, though, provided a forum for several of these opinions. Liz Jarvis reports.
It becomes clear to me that there is a public level of concern, which some might characterize as hysteria, about this issue. That concerns me.
I want to say this, that concern is warranted. We are changing the chemical composition of our atmosphere. There's no question about that. CO2, as you can see on the chart, increases year by year.
And in effect, the concentration of these gases as they continue to rise will produce a change in global climate, which we are having difficulty in identifying when it will occur and what its effects will be. And that is the nature of the uncertainty.
The experts who gathered in Atlanta for the Weather Channel Drought Symposium found a lot to agree about. The drought is severe. The world is warmer now than it has been in centuries, and the public is worried. Is the current drought a normal variation in our climate pattern, or is this the beginning of the greenhouse effect, a preview of things to come?
As of July 1988, you could not look at the data record we have now and say that this is caused by the greenhouse effect, a global temperature here or a drought here. I do not believe you can see that these are caused by the greenhouse effect.
Considering the evidence that is before us, the question is, will droughts like this continue or be more frequent in the future? It's a debatable point. There's some evidence to suggest that, in fact, it may be. But it's not, I think, in our best interest to argue whether this drought is man-induced or related to man-related changes or natural, but rather to accept the fact that this country has drought as part of its climatology, and to be absolutely certain that we are well prepared to monitor it, well prepared to describe it. We can provide timely information to decision makers who have to deal with the social aspects of the drought.
A major problem confronting scientists is that weather is so variable and prone to change that it may be impossible to detect the subtle differences signaling a greenhouse effect.
My prediction for what will happen in the future is that this kind of variability will continue and that there will be no signal detectable with our present available database to say for certain that a greenhouse effect has occurred.
With so little information to work with, researchers have had to rely on numerical models to predict the impact the greenhouse effect would have on the world as we know it. Hecht questioned the validity of these hypothetical scenarios.
And we have in this country several groups which have the computer capability and the team of scientists to try and portray in mathematical terms what we know about the atmosphere. These models project, and I underscore the word project, an image of the future. Many of them project drying in the Midwest and mid-latitudes, but not all. Many of them project the traditional picture or the agreed picture of global warming, particularly in high latitudes. But when it comes down to critical questions, such as increased variability, increased frequency of droughts, changes in the storm track patterns, local climatology, lake levels, they diverge. And therefore, they are not at the point where their resolution will allow us to use them in the sense of making long-term predictions.
So the future is uncertain, but one fact is clear. Man is changing the atmosphere at an alarming rate, the consequence of which will not be fully understood for years to come. But the time for decisive action may already be upon us.
There is a consensus emerging that given the uncertainties and realizing the long-term prospects, that some action must be taken. And I think if there's any lesson that is drawn from our lesson of the natural variability of climate and our emerging lesson of the greenhouse phenomena, is that it is an issue which goes to the very heart of the social fabric of this country and the world as a whole. And I think we will see clear evidence in the months and years ahead that national action will be taken.
For the Weather Channel, I'm Liz Jarvis.
I think this next question will direct to Dr. Oppenheimer. Is now the time to start taking action, or should we wait for more conclusive evidence?
Now is certainly the time to act for two very important reasons. First of all, there's a lag or a delay between the emissions of the gases that cause the greenhouse effect and the full manifestation of their effect, not just on climate, but in the environment. It could be 40 years before we fully realize the consequences of emissions that occur today. So we can't play wait and see. Those effects are also irreversible, so that if we don't like the world we're stumbling into, there's no way to go back. So prudence argues very strongly for starting the move to limit emissions now. And there are lots of steps we can take which will allow us to reduce our dependence on fossil fuels, reduce the other emissions that are causing the greenhouse effect without major disruptions. But it's important to start those moves now, because if we get down the line, things get serious, we get more surprises like the ozone hole, we might have to make radical changes in the way our economy operates, and we'd like to avoid that. Slow, prudent, measured steps begun now to increase energy efficiency, to develop renewable energy sources such as solar energy to replace fossil fuels. Those are the kind of measures that are good news, that are things we should be doing in any case, and there are things we can do now to get the program started.
Briefly, could you outline a few of the steps that you think that we need to slow up this CO2 increase?
Sure. There are three basic important sets of measures we need to take. Number one, increase efficiency in the way we use energy. Between 1973 and 1988, the U.S. economy grew by 30%, but our use of energy was rock stable. That's because we started to develop ways in industry, in the home, to use energy more efficiently. Everyone is familiar with energy-efficient light bulbs, with weatherization, with high-mileage automobiles. Those are steps, relatively simple ones, in many cases relatively inexpensive ones, which can lead us to reduce our fossil fuel use. For the long term, we have to develop renewable energy sources like solar energy, for instance, and solar photovoltaics is a particularly promising way to produce energy, electricity for the future. But if we're going to get the price on that kind of energy down to a tolerable level, we have to invest right now in research and development. We have to encourage industry to look actively for the ways that they can produce solar energy in the future. And a third step, and very important, and something that hasn't been mentioned yet, is deforestation. Trees, forests are made of carbon. When trees are cut down, it adds carbon dioxide to the atmosphere. Deforestation is particularly severe in the tropics all around the world. if we're going to have any luck in reducing carbon dioxide in the atmosphere, if we're going to try to stabilize the amount of carbon dioxide in the atmosphere, one measure that we could take is to reduce deforestation. That's obviously a good idea for lots of reasons.
Thank you very much. Very good points to be looking forward. I think just like the energy crisis or the oil crisis that affected us in the 70s, looks like the greenhouse effect may be affecting us into the future, into the 1990s and maybe in past the year 2000. We'll be back with a little bit more here on the Weather Channel, so please stick with us. Again, our telephone number for your calls as they come in is 1-800-541-6056.
Now stay tuned for the Days In 5-Day Business Planner. America's waking up to Days Ins. As you wake up Monday morning, this is the way the weather mat will be shaping up. This is the kind of weather you can be expecting. Continued dry weather over much of the western third of the country. We will be watching this cold front, though, as it makes its way right on down through lower Michigan, extending back into the Texas Panhandle. A few scattered showers and thunder showers still likely out ahead of this front. And we'll also notice that lingering low-pressure area over New England, keeping the drizzle in place and the light rains and the cloud cover throughout much of upstate New York, right on through the New England area. As we head into midday, notice more scattered showers breaking out along that frontal band and also back into parts of the southwest with moisture feeding up out of Mexico. The monsoonal flow will get the afternoon heating and showers and thunderstorms popping up, especially into eastern sections of Colorado back toward New Mexico, and then more rains out across parts of the Ohio Valley area, mid-Mississippi Valley region as that front makes its way a bit more to the east. Checking on temperatures now, forecast lows for Monday, finding some cool 50s over the northern plains, some 40s back into the higher elevations of the Mountain West, and some 50s too for the higher elevations of New England and also across the Appalachians. Monday afternoon, it warms up nicely, though, into the 80s over much of the Ohio Valley area into New England. Look at the widespread 90s, though, from the Canadian border all the way down into the Gulf Coast area. Around the Permian Basin of Texas, you could see temperatures into the 100s right on down through the Pecos River. 110-degree readings expected out over parts of the southwest. That high heat continues right on through Tuesday. And into Wednesday, we really see the thermometers starting to kick into high gear, measuring those 100s out over eastern sections of Montana, the western Dakotas, western sections of Nebraska, and those 100s moving out of Texas right on up through Oklahoma City, and then widespread 90s all the way back into the eastern seaboard. Very hot weather continuing over much of the nation on into Thursday. Friday, not much change. We'll see those 100s beginning to creep eastward all the way into around southern Lake Michigan, northern sections of Illinois as well, from Winthrop Harbor to Zion, back into Chicago and the Chicago Heights area. Tuesday calls for scattered showers out over much of the west into the Sierra Nevada range, scattered thunder out ahead of a cold front moving on through the Ohio Valley area, and then eventually into New England by Wednesday. More scattered thunder across the Dakotas on down through Illinois and into parts of the high plains, upper Midwest, into the Great Lakes on Thursday as well, then drying out again for most of the west coast, scattered showers across parts of the southeast, and more scattered thunder on Friday across parts of the upper Midwest into the Great Lakes. Now some conditions near you. call about Days Inn's Simple Super Saver program. Restrictions do apply and Simple Super Saver rooms are limited, so call now. And stay with us here at the Weather Channel because very shortly we'll be returning to Dennis Smith with the Greenhouse Effect Special. And we'll be answering more of your questions, so stay with us.
Harry, you know, I'm not cheap. I don't care where you stay, but the company does. The bean counters. Somewhere out there, there's got to be a hotel. Just as clean, just as comfortable, that won't cost an arm and a leg. Harry, you know I'm no cheapskate. If it were up to me, you could stay in the Taj Mahal. But see what else is out there.
Call Days Inn. America's waking up to us.
Harry, they're gonna like you upstairs.
Call 800-325-2525 for reservations at Days Inns nationwide.
Minutes past the top of the hour. Thank you so much for joining us on this special edition of our Drought Watch. We're talking about the greenhouse effect. And I guess the question I want to direct to you, Dr. Grams, is what are some of the projections as far as the years to come and what we think the greenhouse effect may do for global warming?
Well, one thing I thought that might be interesting is to show you some of the results of the calculations done by the Goddard Institute for Space Studies, led by Dr. James Hansen and his colleagues. These calculations are computer models that try to portray the geographical distribution of the changes in temperatures. And the basic graph that you see there shows the light areas being no change, and the yellow and orange changing being hotter temperature, and the blue regions being colder temperatures. The first chart shows the results for calculations from the beginning of the 60s when the greenhouse gases were being measured to the 80s, and the last one shows much hotter temperatures for the 2010s. These graphs do show some regions where it's colder and some where it's warmer. If other modeling groups show their results, they would look a bit different. None of the models are agreeing to the point where there are actual agreement year after year as to what will happen, and each model has to be able to handle all the things that go on in the weather over the years and take into account the increasing gases and the increasing dust particles in the air and so forth, and each group will handle this a bit different. They all predict temperature increases, and the issue is going to be to question whether the models are valid, and whether or not they've included all of the physics. For example, one thing that might be looked at very carefully would be that if you are getting several degrees temperature increase, will you add more water vapor to the atmosphere? Will that water vapor cause an increase in cloudiness? And if you have an increase in cloudiness, won't that reflect energy back to space and cause the Earth to cool down? So issues like that have to be resolved, and all the modelers basically should be trying to get together and resolve any discrepancies. I think there's no real question that the models, if you say let's hold everything else constant, amount of cloud cover and so forth, will increase temperatures.
I'd like to add something in there.
Dr. Oppenheimer, would you like to respond to that?
Sure. What Dr. Grams has said is a good representation of what we understand today, and it's worth noting from the projection that Dr. Grams showed that by early in the next century, if that projection is correct, say the year 2010 or year 2020, the Earth will be warm enough so it will be really noticeable. And that's not in the lives of our grandchildren or our children, that's in our lives. So we're looking at a world which is going to change very fast if the projections are correct, and this will have very large implications for society and for nature. And we have to look at that as something that's starting to happen already. The Earth is already warmer than it was a century ago. That's probably due to the greenhouse warming.
Okay, thank you very much. We have a caller on the line, this one coming from Long Island, New York. Can you go ahead with your call, please?
Hello, I've been wondering if the ice from Antarctica is going to melt and the oceans will rise.
Okay, Dr. Grams, would you like to take that? If the greenhouse effect is there and it's warming, are we going to see melting of the ice and oceans rise?
That's a reasonable thing to expect, that if it is warmer, and especially as those projections were showing that it was warmer in the northern latitudes. You could have ice melting, and that certainly would cause an increase in the ocean level.
What levels are we talking about? A couple of inches, a couple of feet, or what?
Well, it depends upon, again,
how strong the warming is.
How strong the warming is, yes.
Okay, okay. We'll be back with a lot more of your questions and a lot more information to pass along on the greenhouse effect. So please stay with us on our special edition of this Drought Watch.
Many people take everyday items for granted. Take the matchbook, for example. This popular item was invented in 1892 by Joshua Pusey of Pennsylvania. Many products are created or improved by the innovations of individuals. Ideas and inventions come from people in all walks of life. We believe these individuals, like you, are a great source of creativity. If you have an idea, invention, or new product you'd like to submit to industry, Invention Submission Corporation has a free inventor's kit to help you get started. The kit contains a form for recording and dating your invention, an information brochure, and other materials of interest to inventors. Invention Submission Corporation is one of America's largest invention service companies. We can show you how your invention can be packaged and submitted to industry. So call ISC now for your free inventor's kit.
For your free inventor's kit, call toll-free 1-800-288-IDEA. That's 1-800-288-IDEA. Operator 20.
The 36-hour forecast. The 5-day forecast. Stay tuned for more weather updates here on the Weather Channel.
39 minutes past the top of the hour. Again, a special edition of Drought Watch on this Sunday evening. Glad you could join us here on the Weather Channel. We have some more callers on the line. Let's get them in. Let's hear their questions from Iowa City, Iowa. Go ahead, please.
Yes, I would like to know if we begin the stringent pollution control measures right now, would we theoretically be able to stop the effects of the greenhouse effect or even reverse it?
Okay, I think we'll direct that one to Dr. Oppenheimer. Could we reverse this greenhouse effect if we were managed to control the pollutants that are going up into the atmosphere right now?
It appears to be unlikely, but not impossible, that we can reverse the greenhouse effect. And because of that, we have to act as if we can't. So in other words, we have to try not to buy into too much greenhouse effect. The ways that it might be reversed would be growing lots of trees on the surface of the Earth to suck the carbon dioxide out of the atmosphere. But just to give you an example, we would have to reforest an area approximately half the size of the continent of Australia to eat up all the greenhouse gases that we think we're going to put in over the next 40 years unless we act otherwise. There's some chance that if we got emissions down low enough, the oceans could take some of that carbon dioxide out of the atmosphere as well, because under normal circumstances, they do eat up some of the carbon dioxide that's emitted. But we have to basically act as if the emissions that we put into the atmosphere are there to stay permanently, because it looks like they're there for hundreds, if not thousands of years, no matter what we do. And that means starting to limit those emissions today.
Okay, thank you very much. We have another question that's coming to us from Muscatine, Iowa. Go ahead with your question, please. Hello, Muscatine, Iowa. Can you come in, please? Okay, let me ask you, is this greenhouse just confined to the United States, or are we feeling this entirely on the globe?
This effect would be worldwide. There would be no reason to expect that one country would be preferred over another as far as these calculations.
So we're feeling it all over the entire
Certainly,
globe. It's
yeah.
not just confined to the U.S. and its drought right now. It's an effect that we're going to feel all over the entire globe.
That's right. It's a global calculation, and there are no boundaries.
No political boundaries
on this one.
Everybody has to work together. We have another question. This one coming from Charleston, South Carolina. Go ahead with your question, please.
Yes, Dr. Oppenheimer mentioned the tropical deforestation. Considering the present level of massive deforestation of the tropical areas, I was wondering if he has any feel for when the remaining vegetation on the Earth will no longer produce a sufficient quantity of oxygen to replace that which we breathe.
The removal of oxygen by deforestation, or rather the removal of the mechanism by which trees put back oxygen into the atmosphere, is a problem, but not on the kind of time scale that we're talking about with regard to the greenhouse effect. The greenhouse effect is something that's occurring now. The oxygen problem is something that you might worry about over tens or hundreds of thousands of years. It's not a concern for today. I would like to interject something in response to a previous question, and that is from the question on Long Island about sea level rise. That's a good place to ask the question from, because beaches are eroding on Long Island and along the whole Atlantic seaboard of the United States. That erosion is occurring partly because sea level has been rising due to this warming for at least 100 years, and the rate of sea level rise will be 5 times as fast over the next 100 years. Now, what we expect is a rise in the vertical sea level of about 1 meter or so over the next 100 years, and what that means on the typical beach is a loss of 500 meters, and about 1,500 feet inland. That's a very, very substantial beach loss. It's not clear that we can keep up with that by repiling sand on the beaches. That's something that everybody is going to notice.
One thing that you commented on earlier was the fact that the forests, because we're cutting them down, we're aiding to the greenhouse effect. How much of an effect would you say the acid rain, by actually destroying some of the vegetation, is contributing to wiping out some of our forests that we need?
Acid rain has been damaging forests all up and down the Appalachian chain of the eastern United States, and at some lower elevations as well. That does not yet appear to have had an effect on the amount of carbon dioxide in the atmosphere. But it's very troubling, because as the third world industrializes, it's possible that the same effects will occur in the tropics, where we have the lush tropical forests. And even if we get direct deforestation underway, it's possible that the destruction of those forests will accelerate due to air pollution. By the way, I misspoke a second ago. If the sea level rises 1 meter, that means 100 meters of inland beach loss. In other words, about 300 feet.
Okay, thank you very much. We'll have some more of your questions to answer momentarily. Please stay with us in our special edition of Drought Watch on the Weather Channel.
Time magazine has put together a very special free gift for subscribing. It starts with something everyone needs: a telephone, with automatic redial, a ringer shut-off switch, and a mute button. But when you're on the phone, it makes sense to have a calendar handy. So we've added a permanent calendar. And when you need the date, you often need the time, too. So we've included a digital clock. And then, for all those important messages, we've built in a memo pad, which means you'll need a place for your pen or pencil. So here's a pen and pencil holder. It all adds up to the Ultronic 4-in-1 phone center, and it's free with your paid subscription to Time. Call this number and enjoy 26 weeks of Time for more than 40% off the cover price, payable in 3 monthly installments of just $9.89 each. Call 1-800-284-5300 now. It's the most remarkable offer Time has ever assembled, including this handsome 4-in-1 phone center, free.
Programming of the Weather Channel is protected under the copyright laws of the United States and is intended solely for the use of our subscribers. Reproduction or other use of this programming without the express written permission of the network is prohibited.
The 36-hour forecast. special regional information. Stay tuned for the latest weather information here on the Weather Channel.
Thank you so much for joining us on this special edition of Drought Watch 1988 here on the Weather Channel. We've got some more phone calls on the line, so let's take one from Austin, Texas. Go ahead, Austin.
Yes, this is Jack Masters. I'd like to ask Dr. Oppenheimer if there's any scientific tie-in between the greenhouse effect and the holes in the ozones on the extra poles.
Dr. Oppenheimer, you want to tackle that one?
Sure. There's one very direct connection. The loss of ozone over Antarctica and to a lesser extent over the rest of the globe is due to the emissions of certain industrial chemicals called chlorofluorocarbons. Those chemicals are used in air conditioners, refrigerators, to blow plastics, and as solvents. Those same chlorofluorocarbons also contribute to the greenhouse effect. Now, there was a treaty signed in Montreal by about 30 nations last September, which will cut those emissions in half. But there will still be enough chlorofluorocarbons to continue to cause a deterioration of the ozone layer and to continue to contribute significantly to the greenhouse effect. So one of the first jobs our government has in trying to deal with the greenhouse effect is have that treaty renegotiated to eliminate completely the emissions of chlorofluorocarbons, because there are substitute chemicals and substitute processes that are becoming available. We're not going to need those chemicals.
Okay, thank you. Next call comes from Winchester, Virginia. Go ahead, please.
Well, it occurs to me that increased heat means increased evaporation and also increased water available for evaporation due to ice melt worldwide. Thus, after a brief drying period, 5, 10, 20 years, there would be more storms and more precipitation, thus causing more vegetation growth, offsetting the greenhouse effect. How valid is that in keeping with the Gaia hypothesis?
We talked about that earlier. Is you have an increase in CO2, you'd have increase in maybe later down the line, increase in clouds and precipitation, and like the question was, can we reverse this? Is just a little pitch of dryness, or are we going to see a cooling because of cloud cover, or what?
Well, I don't know for sure if we can regard this as controlling it by reversing it by some means of control. The change in the precipitation, the change in the cloud cover and so forth is entirely up to nature. But that's right. If you increase the Earth's temperature and cause more evaporation, you could cause more clouds, and the higher reflectivity of the Earth might counteract this. It's something that has to be addressed. It has to be looked at very carefully. The models have to be validated and improved. But until more research is done in this, I don't think that these kinds of so-called feedback effects are understood to the point where we can really give an absolute answer on any of those questions.
Okay. I'd like to
Next question. Yes, sir. I'm sorry. Go ahead.
We can speculate on another kind of feedback, one that would work in the opposite direction, and which is related to the question. One of the things that might happen with the warming is that forests will start to decline for the reasons I described before, namely they're no longer living in the right climate. If forests decline, that may further accelerate the greenhouse effect by, in fact, pouring more carbon dioxide into the atmosphere, because, as we said, trees are a reservoir for carbon. So we've got to be concerned that if we get too far away from the current conditions under which we live, we're wandering off into a no man's land where we simply don't understand the world that we're buying into. And a prudent course would lead us to avoid such an eventuality.
Dr. Oppenheimer, let me ask you this. What can an individual, what can we do, the Joe Blow out there, do to help turn this thing around? It looks like we're in a mess. How do we straighten it out?
There are two things that the average person can do. There are two types of things: actions that you can take in your own life to limit your energy use, and number two, political actions you can take. And I'll deal with the second first. Politicians are starting to get very concerned about this problem because they've seen the TV reports just as you have. And one of the things that you can do is give backing to those politicians which have shown an interest in greenhouse warming. Let them know. Write letters to your congressman. Write letters to everyone in Washington who has a say-so in this. Let them know you want this problem dealt with now. But at a personal level, there are lots of actions the individual can take. Let's start driving high mileage automobiles. Let's go back to what we started to do in the 70s. Have everyone examine whether they're using energy efficient light bulbs or not. Have your houses weatherized. There are lots of individual efficiency actions that we all can take.
Okay, sounds like we've got a lot to do, and 1988's a big year for politicians for their jobs, so it looks like maybe we can talk to them and see what we can get done for at least 1988 about our future. Well, that just about wraps it up for this special edition of the Weather Channel Drought Watch. Dr. Graham, thank you so much for joining us. We appreciate it.
Pleasure
and again, Dr. Oppenheimer in New York City, thank you also for joining us this evening.
Pleasure to be here.
We have another hour-long specials in the works here at the Weather Channel, so mark your calendar for August 21st at 6 p.m. Eastern Time for John Hope on hurricanes. Then a week after that, on August 27th, very similar to what it was tonight, Global Crisis, an examination of some of the dangers lurking in our environment. And as usual, the Weather Channel Drought Watch continues every day at noon and again at 8 p.m. For those of us here on Drought Watch, good night.
The 36-hour forecast. Day forecast. Stay tuned for more weather updates here on the Weather Channel.
It's about 5 minutes in front of the hour. Time now for the Michelin Driver's Report. Michelin, because so much is riding on your tires. Be careful traveling through parts of the Northeast as we take you on into Monday morning. You're going to see some scattered rain showers continuing into Maine, northern sections of New England, lingering low pressure over the area, more of the clouds and drizzle from upstate New York right on in through Caribou, Maine. Also out ahead of that cold front as it moves on down through lower Michigan and back into northwest Arkansas, you'll see scattered showers continuing from around Detroit down through central sections of Illinois near Peoria, down through Cape Girardeau, Missouri, all the way back into Siloam Springs, Arkansas, and Benton County, and into near Oklahoma City. Eastern counties of Oklahoma still affected by the rainy travel. Severe thunderstorms a possibility out ahead of this cold front from lower Michigan all the way back into parts of Oklahoma and around the Texas Panhandle. Strong storms still a possibility along the eastern seaboard, those areas shaded in orange, and also out over parts of the southwest. Don't forget, we do have a severe thunderstorm watch in effect now until 10 o'clock Central Time for parts of eastern sections of Nebraska into Iowa. That area shaded in yellow, and also a severe thunderstorm watch in effect for much of Oklahoma and a few counties in the eastern Texas Panhandle until 10 o'clock.